Hi, I'm Mathroberg, and today our goal is going to be to graph y equals sine of x. Now, one definition for describing what sine is this definition. Sine of some angle theta equals y over r. So let's graph a few different thetas and see what value we get for y and r. First off, r is the measurement of this radius. Let's draw one right here. The length of this little segment is 1. So maybe right here I'm just going to write r equals 1. Just so we remember, the length of that segment I just drew is 1. If the length of that segment is 1, the coordinate of the points right here would be 1, 0. Since the y coordinate is 0 and r is 1, sine is 0 over 1 at that particular angle. We call this the initial side, and we start rotating it to a terminal side. So if the initial side is on top of the terminal side, our theta is 0 degrees. Down in our table here, we're going to let theta be x. Because ultimately, our goal is to graph x, where x is a certain number of degrees, or x is a certain theta. So right here, if we have 0 degrees, we just found out at 0 degrees we have 0 for y and 1 for r, so back in our function up here, we get 0. So there's our first coordinate. Now let's imagine we rotate theta 90 degrees. So now we're up here. While r is still 1, the new coordinates of this point are 0, 1. So we have 1 over 1. So in our function, when x is 90 degrees, y is 1. Let's rotate another 90 degrees down to here. So now we're at 180 degrees. At 180 degrees, our coordinates here would be, let's see, -1, 0. So y over r would again be 0. Let's try it for 270. At 270 degrees, which is down here, our coordinates are 0, -1. So that means y is -1 here, because it'd be -1 over 1. And if we keep going all the way to 360, at 360, we're back at that initial side. We're back at 0 degrees. So 360 is going to match the 0. And in fact, if we keep going by 90 degrees, since 450 is coterminal with 90, this will also be 1. These are all just going to keep repeating if we were to continue this table. And that repeating aspect of the sine function is important. Let's try to put all this together on a graph. All right. Our first point we're going to graph is 0, 0. But before that, we should probably scale our graph appropriately. Since our values fluctuate between -1 and 1, maybe a good label for our y-axis would be, let's make this -1 down here. We'll make this 0, and up here, +1. For our x-axis, we're increasing by 90 degrees. All of these 0s, 1s, and -1s are happening at multiples of 90 degrees. So if we make our x-ticks 90 degrees, it will make it easy to graph. So let's make this 90, 180, 270, 360. We're just going up by 90. So on this side, we'll have -90 and -180. All right, now we're ready to graph. And let's do this in blue. All right, 0, 0. So our x coordinate 0, y coordinate 0. That's right here. 91. So at 90 degrees, our y coordinate is 1. So 90 degrees, here's 1. 180, 0. 270, we're at -1. 360, we're at 0. And let's stop there, because what we've actually completed right now is one cycle. This is called a period. Or the cycle completes in a period. It took us 360 degrees, that's the period, to complete one cycle. So here's what the sine graph looks like. Well, somewhat. It doesn't have little bumps in it, but that's what you get when you freehand this. If you memorize this pattern, it's super helpful because it repeats over and over and over again. We see once we're at 450 degrees, we're essentially where we were at 90 degrees. So you can repeat this pattern over and over and over again. Here's how I do it. I find a starting point for the cycle. In this case, 360 is the same as 0 degrees. I know this whole cycle has to complete in one period. Since a period right now is 360, 360 plus 360 is 720. So I know my whole sine cycle is going to complete between these 2 points. Go halfway between those points and put another point at 0. So halfway between these is 540. Now you've divided this into 2 segments. You've got this segment and this segment. If you look at the middles of each of these segments, so the middle of this segment, that's where sine is going to maximize. So the middle of this is when we're going to be at 1. The middle of the other segment is when we're going to be minimized, down at -1. So you've got these 5 points. This is called the 5-point method sometimes. And when we connect them, we can see that repeating pattern of sine. If we connect that pattern over here, just to get some stuff in our negative side of the y-axis, negative side of the x-axis, there we go. That's the graph of y equals sine of x.